Alright, so I'm going to pick up where we left off on the last video, which was, again, going over SAT practice test number 4, section 3, and I just finished problem number 10, so I'm going to go on to do 11 right now. And the question poses x equals 2y plus 5 and y equals 2x minus 3, x plus 9. And it asks how many ordered pairs, x, y, satisfy the system of equations shown above, which are these two equations. And you have A, which is 0, B, which is 1, C, which is 2, and D, which is infinitely many. All right. So basically, the first thing that you might want to do is rearrange it so that everything looks the same. I don't think I've used orange yet. So what I want to do is rearrange this equation so it's in the form y equals something. So I would have 2y equals x minus 5, and then divide both sides by 2, y equals 1/2 x minus 2.5. Sorry for the fraction and decimal mixed notation there. All right. From here, basically, I'm not quite sure how much this is taught in high school, but what you would want to consider is what solutions this equation here has for y equals 0. So if you expand this out, you would get y equals 2x times x is 2x squared, and then 9 times 2x is 18x, minus 3 times x is minus 3x, minus 3 times 9 is minus 27. So simplify that, 2x squared plus 15x minus 27. Okay, so if you were to graph this, what it would look like, right, so x, y, is this is just a parabola, okay, so it's going to look something like this, okay, this equation here, so this is number 1, should have used a different color, but I won't now. This is number 2, right? So now if you graph this is a line, right? The slope is 1/2, and in previous videos I've graphed lines, so I'm going to do that again. So x equals 0, y is just going to equal minus 2.5, y equals 0, so that's one set of points, 0, 2.5. Now set y equals 0, and then you're going to get 2.5 equals 1/2 x, so x equals 5. So that's your second pair, 5, 0. So now if you plot that 0, 2.5, that'd be something like here, and then 5, 0 might be something like here. It might be over there or over there. It's not so important. Okay, and so that's what both of these plotted looks like, and what it's asking is where does it intersect, and where they intersect is where the solutions to this set of equations will be. So it intersects here and here, which is 2. But I drew this kind of generically. It might have, there's a couple other ways you could imagine this working. So if this line gets shifted down a little bit, you know, if this equation instead of 1/2 minus 2.5 is, you know, 1/2 plus 10 or something. So let's see what would happen if instead of y equals 1/2 x minus 2.5, y equals 1/2 x plus 10, okay, then set equals to 0. Sorry, I want this to be, this should be minus 2.5, and so this should be shifted down a little bit, kind of down there, look like that. But you still get these two intersection points here. So, but if you shifted this down, this is minus 10, all right, then y equals 0 minus 10, y is minus 10, then you might get something that looks like this. and then the green line and the orange line don't intersect at all, and you get no solutions. Or you might have another situation where it intersects exactly at one point. So that's pretty much what this is asking, is where do you have the intersection of these two lines? Basically, so basically, what you're looking for is where these intersect, and they'll intersect when, so you have these two equations here, y equals 1/2 x minus 2.5, and y equals 2x squared plus 15x minus 27. So what you can do is just set them equal to each other, so 1/2 x minus 2.5 equals 2x squared plus 15x minus 27. And if you rearrange things, you'll get 0 equals 2x squared plus 15.5x, and then minus 27 plus 2.5 is minus 24.5. And this is just a palabra. This is just a quadratic equation. And so you know that this has two solutions. You probably want to check that these are real, but that's relatively simple to do. So now we'll go on to 12. All right, and this is a word problem, so I'll just read it and take notes as I go. So Ken and Paul each ordered a sandwich at a restaurant. So the price of Ken's sandwich, which is Ken, was X dollars. And the price of Paul's sandwich was $1 more than the price of Ken's sandwich. So Paul was whatever Ken's was plus 1. Okay. Ken and Paul split the cost of the sandwiches evenly, and each paid a 20% tip. Which of the following expressions represents the amount that each of them paid? Assume there's no sales tax, which is nice. So the total then would be Ken's sandwich plus Paul's sandwich, right? Before tip, total before tip. So that would be x plus 1. It's going to be 2x plus 1. And now we need to find the tip. And so the tip is going to be 20% of 2x plus 1. And so 20% is just 1/5, right? So 1/5, and of is multiply 2x plus 1. Okay. So then total with tip is going to be 1/5 of 2x plus 1 plus 2x plus 1. So this is the tip here, and this is the total. Right, so this is the tip, and this is the total before tip. Before tip. And so if you add these together, you're going to get 2x plus 1 times 1 plus 1/5, which is going to be 1.2, because this is just 6/5, which is 1.2 times 2x plus 1. And if you look at the solutions, you probably, do you see that? Oh, you do see that, right? So then you're going to have 2.4x plus 1.2. That's not the solution, because this is the total with tip. And then you have to remember that they split it. It's asking how much each of them paid. So divided by 2 is going to be 1.2x plus 1.2 divided by 2 is 0.6. Right? And so this is C. Right? Let's go on to 13. All right. And you are asked about a graph, which is again two palabras. So I'll replicate it here for you. So the blue is f of x, and the orange is g of x. Okay. And it's asking about, and basically what it says is that this intersection point here, here, and here, this is minus k, 0, and this is k, 0, all right? And ask what is the value of k? Close the question mark, okay? And again, where you have two curves intersect is where they're equal to each other. So you're going to have g of x equals f of x at minus k, 0, and at k, 0. All right. And you're actually given that g of x is minus x squared, minus 8x squared plus 2, and f of x is 8x squared minus 2. So you just set these equal to each other. So you're going to have f of x equals g of x, okay? And now you just solve to find out what k is. So this is going to be 16x squared equals 4, okay? Divide both sides by 16. X squared equals 4 divided by 16, which is a quarter. And now you just have to remember how to square root a fraction. So that's x is the square root of 1 divided by 4, which is square root of 1 divided by square root of 4, which is 1 divided by 2. Okay. And so that is what k is. Okay. And so if you look at the answers given, that's B. Alright. And let's do one more. I guess maybe just so we don't end on 13. So 14, alright, you're going to have to use your imagination. Dealing with complex numbers now. So you have 8 minus I divided by 3 minus 2I. Alright, and you have to rewrite it, and it basically wants it in the form A plus BI. Alright, where I is the square root of minus 1. Okay, and it wants to know what is A equal to. Is equal to, not equal to 2. Freudian slip. So basically what you want to do is just, there's this kind of a special, it's not super special, you do the same thing with square roots, but when you have anything of the form something divided by A plus BI, in order to get this imaginary part out of the denominator, you're going to multiply by its conjugate. So what the conjugate is whenever there's an imaginary number, you just put a minus sign in front of it. So A minus BI. And you can do this because this A minus BI divided by A minus BI is just 1. So if you do that, you do A, just multiply. So A times A is A squared. A times minus BI is minus ABI. BI times A is plus ABI. And then BI times minus BI is minus BI squared. And this I squared is minus 1 equals to I squared. So what you get, A minus ABI and plus ABI is 0. So you get A squared plus B squared. Okay. So we're going to do this here, right? And so you have 8 minus I divided by 3 minus 2I, multiplied by 1, but creatively. The trick to algebra is multiplying by 1 and adding 0 creatively. All right, and so from what we just went over, we know that this should equal, the denominator should equal A squared plus B squared, so it should be 9 plus 4, so we're expecting this to be 8 minus I times 3 plus 2I divided by, this should be 13, but we'll check that. So if we multiply the top, then you're going to get 24. And if you wanted to kind of be quick about it. You wouldn't even have to multiply the inner products because you're only caring about A. And I'll just demonstrate that quickly. So I'm just going to skip over completely expanding this and just do 8 times 3 is 24, and then minus I times plus 2I is going to be minus 2I squared, which is going to be plus, so it's going to be 26. So you can kind of guess your answer should be 2, which is A. All right, I'm going to do that a little bit more rigorously. All right, so you're just going to have on the denominator, you're going to have 3 times 3 is 9, then plus 6I minus 6I minus 4I squared, which is going to be plus, so that's going to be 13, and then the top is going to be 24 plus 16I minus 3I, and then minus 2I squared, which is going to be 26 minus 13I. So overall, you get 26 minus 13I divided by 13, which is 2 minus I. Okay, so again, the answer is A. All right, thanks for watching that, and I hope you can catch me on the next video.